Welcome back to lecture number 4 on kinematics. This is our equation. V squared equals V naught squared plus 2AX. You notice in this one we have two V's but no time. So when you're trying to figure out which equation you're going to use and you don't see a time, look for this one, especially if you have the acceleration. So we got a car traveling at 15 meters per second. Okay, we're not going to put the naughts yet until we get everything set at a rate. Okay, meters per second squared is A for a distance of 50 meters. And you can see the new velocity. In other words, we're looking for the V naught squared plus 2AX. That's our equation we're using in this section. So V squared equals, now the begin is traveling at 15, don't forget that square, 2 times 3.2, and it traveled for 50. We're going, since we're not looking for V squared, we're just looking for V, and it's in meters per second. Here's another one. Let's go on and write down our equation, since that's our equation for this lecture. Now the runner is traveling at 5.4 meters per second. So there's our V. Wants to stop. Now just remember, stop means that V equals 0, or at rest. There's another way that it can be worded, and there's our made a mistake there. That should be in, let's see, make that in meters. So what's the runner's acceleration? So let's see what we got. Okay, now you got to remember it was traveling at this much, stopping, so this is our original, this is our final, squared equals, that's 5.4 squared plus 2 times A times 2.1, we just changed that, okay, A will be in meters per second squared. Now I'm probably give you a little hint, since we're stopping, your acceleration better turn out negative by convention. Okay, here's one. Okay, let's write down our equation that we're doing. Okay, it was traveling at this, there's V. Slows, that could make a difference, to this. At a rate, there's A, and then we want to know how far. So our second, we slowed it to 21. We were started at 40. We got 2. Now, we got 5.8 meters per second here. Is that positive or negative? Well, let's see, we went from a high velocity to a lower, so we're slowing down. In other words, we're decreasing, so our acceleration is negative, and we're wanting X. So X is in meters. Let's write this down. Okay, car traveling at 80 meters per second. Know thy units, works every time. Slows at a rate, just like the last one. So I bet you this is going to be a negative to a distance of 30 meters, and we wanted to know the initial. So there's 80. We want the initial. may not be worded, but we're going to solve it just the way it is. Times 30. And since my letter, I'm just going to put this down here, is in meters per second. I could probably say had slowed to make it a clearer one, since I was looking for the initial. Let's do one more. Runner can accelerate. So there's our equation for today. Okay, it says we want the new velocity, so we got A and X. Well, it said can accelerate. Well, since I didn't really give you that, we're going to assume that this started from rest, which is, let's see, right, if I can spell that, rest. Okay, plus 2 times 7.4 times 15, and V will be in meters per second. These should give you enough examples for you to work. We have some more that you can do on your own. And if you have any questions, feel free to contact me.